All right, welcome everyone. Today, we're taking a deep dive into the very heart of modern LNG-fueled vessels, WinGD's innovative dual-fuel engine technology. Consider this your guide to mastering the systems that are, quite literally, powering the next generation of shipping.
So, here's our game plan for this explainer. We've got a lot to cover. We're going to start with the absolute foundation, the safety rules. Then, we'll follow the fuel through the system, get to know the digital watchdogs that keep everything in check, walk through the key operations you'll be doing, and finally, wrap up with some really crucial lessons learned from thousands of hours out at sea.
Okay, first things first, and it's always got to be safety, right? Before we touch a single piece of hardware or look at any software, we need to understand the rules and the core design thinking that make these incredibly powerful engines safe to operate. You've got to understand everything we're about to talk about, every single procedure, every component. It's all built on the foundation of the ISGF code. This is the international rule book. It governs the safety of all gas-fueled ships. Period. It's the baseline that makes sure safety is baked in from the very beginning, influencing every single design choice you're about to see. So, the key thing to get here is that this isn't just about one safety feature. It's a whole philosophy, a multi-layered defense system. Think of it like a fortress. You've got the physical barrier, the double-walled pipes, you've got constant surveillance from the gas detectors, you've got an immediate, automated response that always defaults to the safety of diesel fuel, and on top of that, you have a fail-safe purge system for maintenance. It's safety through and through. Okay, with that safety foundation firmly in place, let's follow the fuel. We're going to trace its path and look at the key hardware that makes this all work, from the second the gas gets to the engine to the moment it's put to work inside the cylinder.
Take a look at this. This schematic is basically the roadmap for the gas on the engine. Gas comes in from the supply, goes through that master shutoff valve, and then hits those super important double block and bleed valves. That's your fail-safe shutoff. From there, it heads to the cylinders. And notice the different color-coded lines for purging and venting? Those are those critical safety functions we just talked about. It's a really clean, well-thought-out design. And this little guy? This is the gas admission valve, or GAV. This is where the real action happens. After that gas has traveled through all the pipes, this valve is responsible for injecting the perfect amount of gas into the cylinder at precisely the right millisecond. It's a key player in that low-pressure combustion process that makes these XDF engines what they are.
Now, a quick history lesson here, because it's important to know where this tech came from. The first generation was the gas valve unit, the GVU. It was this big external box that needed its own room. The new standard, what you'll see now, is the IGPR, the Integrated Gas Pressure Regulation System. And just like the name says, it's mounted right on the engine, which makes things a whole lot simpler for installation and communication. All right, so we've got the safety rules and we've got the hardware. Now let's talk about the brains of the operation, the control systems that are working every single second to make sure everything is safe, reliable, and efficient.
This diagram lays it all out. Think of it like this. The engine control system, the ECS, is the day-to-day manager. It's handling performance, fuel mix, all that stuff. But the engine safety system, the ESS, that's a completely independent system. It's the ultimate bodyguard, hardwired to watch for critical problems and take action, even if it means overruling the ECS. And this table really boils down the system's logic to its core. It's all about if this, then that. You can see, for something like engine knocking, the ECS triggers a gas trip. Boom, you're safely back on diesel. But for something more serious, like a gas leak or an overspeed event, the ESS steps in and forces a trip or even a full shutdown. The system is designed from the ground up to always feel safe. Okay, knowing the hardware and software is one thing, but how do you actually run it? This is where it all comes together. Let's walk through the key operational sequences you'll be performing step by step. Before we get into the step-by-steps, you have to burn these rules into your brain. These are not suggestions. They are hard-coded safety interlocks. You will always start in diesel. You will only reverse in diesel. If you stop in gas mode, the next start will automatically take longer to purge the cylinders. And if you get a gas trip, you can't go back to gas until you've cleared the problem. Simple as that. So, you hit the button to go into gas mode. What happens next? Well, it's not instant. First, the system does its own checks, performing a leakage test on the main valves. Only when that passes does it open the gas supply. Then you see this beautiful, smooth ramp-up of gas while the diesel ramps down. It's a completely seamless handover. Now, going back to diesel, whether you command it or the system does it automatically, is just as smooth but a whole lot faster. Look how quickly the gas valves close and the diesel injectors kick in. There's no hesitation.
This ensures you have continuous, uninterrupted power, which is absolutely critical for the safety of the vessel. Okay, but what about a real emergency, like an overspeed? This is when the system doesn't ask questions. It immediately trips back to diesel, shuts off all gas, and then cuts all fuel. And just as important, it then requests a full exhaust ventilation to make sure the entire engine is clear and safe for the next start, once you figured out what went wrong. All right, we've been talking a lot about how things should work, but theory is one thing, right? Practice is everything. So let's talk about the invaluable lessons learned from hundreds of thousands of running hours out there on the water. This is where the rubber really meets the road. And the first thing you see from the field is, wow, these things are reliable. We're talking 97 to 98% availability of gas mode on ships with these engines. That's incredible. It tells you that these vessels are basically living on gas, only switching to diesel when they're maneuvering in port. But, with any new technology, you're going to find little things you didn't expect. Early on, one of those was some clogging on the main diesel fuel injector nozzles. And it makes perfect sense when you think about it. If you're running on gas for weeks at a time, those diesel injectors are just sitting there, getting baked by the heat of the engine. And the fix for this? It's so simple, it's brilliant. They came up with what we call cleaning shots. About once a week, you just manually switch over to diesel for a few minutes. That powerful blast of diesel fuel through the injectors is enough to completely clean out any gunk that might have built up, keeping them ready to go. Okay, another puzzle from the real world, cylinder lube oil. It's pretty straightforward, really. Natural gas is a super clean fuel, so it needs one type of oil, a low BN or base number oil. Diesel, on the other hand, often has sulfur, so it needs a high BN oil to fight off acids. The trick was making sure you had the right oil in there right after a fuel change. And that challenge is exactly why iCAT was invented, the Integrated Cylinder Lubricant Auto Transfer System. Instead of a manual process that could take hours for the new oil to work its way through the system, iCAT does it automatically. It took a process that took hours and crunched it down to about 1 minute. That's a huge deal for engine protection. And that really brings us to the main point here. This XDF technology is solid, it's proven, it's highly reliable. But, and this is a big but, it's not standing still. The development never stops. Every lesson learned from every ship at sea is fed back to the designers to make these engines even better, safer, and more efficient. So, as we wrap up, I want to leave you with this thought. The industry is already full steam ahead developing engines for the fuels of tomorrow, like ammonia and methanol. And guess what? The core principles, handling 2 different fuels, the automated safety systems, the operational discipline, it's all the same. The skills you're building today, mastering these dual fuel systems, you're actually getting a head start on safely operating the zero-carbon engines of the future.